Good morning. Today we will discuss about the energy conservation, and different sources of energy. In last class, we studied about the energy definition, different types of mechanical energy, and derivations for the potential energy and kinetic energy. Energy is nothing but it is a capability to do the work. Energy units in the SI system are joule, in CGS erg. We know that energy is a scalar quantity. So in our syllabus we have mechanical energy, we have the different types of energies in our world. For example, solar energy, wind energy, tidal energy, geothermal energy, hydro energy, etc. We have the different types of energies. We discussed in last class about the mechanical energy, that is potential energy and kinetic energy. Today we will discuss about energy conservation. What is the energy conservation? How it changes from one form of the energy to another form. In our syllabus we have the conversion of potential and kinetic energy, that is the conversion of the mechanical energy into different forms. We have to prove this energy conservation in case of a freely falling body and in case of a simple pendulum. In our syllabus we have only freely falling body. Otherwise we can prove the body is projected upward, and also when it is coming downward, means it is coming from the maximum height, freely falling body. And energy sources, different types, two types. One is the non-renewable energy source and another one is the renewable energy source. We will discuss about these chapters in today's lesson. So energy is a capability to do the work, right? Energy consumed by the body is equals to the work done by the body. It gives the work energy theorem we already discussed in last chapter. What is conservation? Conservation means changing from one form to another form, but whole energy remains constant. So we can change the energy from one form to another form. For example, electrical energy, when you switch on the light glows, bulb glows. So it gives the light energy, and after some time you touch the bulb, touch the light, you feel heat. It is hotter, right? So the electrical energy is given to the bulb, it's converted into light energy and heat energy. The heat and light are not produced here, right? Or electrical current is not destroyed, but this electrical energy is converted into light and heat energy in this case, right? Like that, every energy is transforms from one form to another form, but it cannot be destroyed, it cannot be created. We are not creating new energy, we are not destroying the existing energy, but we are changing the form of the energy to another form of the energy. But whole energy, the total amount, for example this electrical heat and electrical, the sum of the total remains constant. For example, first you are supplying the 230 volts energy, the heat and current, whatever the consume energy by different sources, light, fans, fridge, etc. in the whole system, that equals to the whatever you are supplying the energy. So here energy is not created. So law of conservation of energy or energy conservation law. Energy conservation law can be defined as energy can neither be created nor destroyed. Energy can neither be created nor destroyed, but one form of energy can be transformed into another form of energy. Energy can neither be created nor destroyed, but one form of energy can be transformed into another form of energy. But the total energy of the whole universe remains constant. The total energy of the whole universe remains constant. This is the law of conservation of energy or energy conservation law. This is most important question for the examination point of view and for the competitive purpose. In ESET like exams, you will get a question when the body is projected up or body is freely falling from the maximum height. In between the path of the body, he will ask some question, velocity or height. If body is projected up and one body is falling down, at which height both the bodies comes meets at which height, or what is the velocity of different positions. This type of questions rises in the competitive examinations. So energy conservation law, energy cannot be created nor destroyed, but one form of energy can be transformed into another form of energy, and the total energy of the whole universe remains constant. Right? Next, we have a proof. We have to prove that one form of energy converted into another form of energy. Consider in our syllabus we have a freely falling. We have to prove in case of freely falling body. What is a freely falling body? When you throw a object, any body, it goes certain height. After some height, its velocity becomes 0. For example, this is the ground. You are throwing a body exactly upward direction, right? After some time, its velocity becomes 0. At this point, its velocity becomes 0. When its velocity becomes 0, it will not go further beyond that particular point. From that point, it comes down. This is the height it reaches maximum. The maximum vertical displacement is called a maximum height, or where the body's velocity becomes 0. Final velocity becomes 0. That point is called as a maximum height. This is the maximum height reached by the body. From this maximum height, the body comes down. At this point, its velocity becomes 0. This is the when it is going up. This is the u initial velocity, and this one is the v final velocity. When it is coming down, this becomes its initial velocity. This is the initial velocity, and when it reaches the ground, that is the final velocity. So here this is initial velocity. So it is moving with a 0 initial velocity. No one is pulling or no one is pushing. It is coming down due to the gravitational pulling force only. Its initial velocity is 0 at maximum height. That type of bodies are called as a freely falling bodies. Now the body is at consider the body mass is m. Consider the mass of the body is m. It is falling freely from the height h. The height is h. This is the body A is at position A. It is at the certain height h, and its mass is m. and its velocity is 0. Initial velocity is 0. So this velocity is taken as velocity of at position A. I am taking this as velocity at position A. So the total energy, mechanical energy, is combination of potential energy and kinetic energy. What is the potential energy here? Potential energy is mgh, right? At the point A, the potential energy is mgh because it has mass, it has gravitational pulling force downward, and it has a h height. And what is the kinetic energy? Kinetic energy at A equals to half mv a square. Here, what is the value of velocity? Velocity value is 0. So total term becomes 0. Kinetic energy becomes 0. At point B, at point A, at position A, potential energy is mgh, kinetic energy is 0. Potential energy is mgh and kinetic energy is 0. So total energy at A equals to potential energy at A plus kinetic energy at A. What is the potential energy? mgh. And what is the kinetic energy? 0. So total energy at A is mgh. This is the total energy at position A. Right? Now it is falling down. It is falling down. It travels some distance x, then it reaches the point B. It reaches point B. The travel distance, this is the distance traveled by the body. The travel distance is x. Then what is the height? Height will be h minus x. Total height minus it traveled, so it is h minus, its height is h minus x from the ground. At position B, the body is falling down. The body is falling down. So at position B, what is the potential energy? Potential energy equals to, at B equals to mgh, but h equals to h minus x. H minus x is the height. See the figure. It travel distance x distance travel, so that this is the height from the ground. So potential energy at B equals to mgh. H equals to h minus x. Therefore potential energy becomes mgh minus mgx. This is the potential energy at point B. So now I have to find out the kinetic energy. Kinetic energy at B equals to half mvb square. The velocity at B is taken as vb square. Right? So what is the value of velocity at point B? We don't know the velocity at B, so you have to find out the velocity at B. So the body is falling down freely, so initial velocity is u, and velocity at VB, point B is VB, and covered distance, travel distance is x, and acceleration is equals to plus g. It is coming down, so it is plus g. Therefore from v square minus u square equals to 2as. Using this equation, we can find out the velocity at point B. What is v? Initial velocity, final velocity, vb square. This is the final velocity for us in this case of when we are studying the a body at the point B. So 2gs equals to x. So vb equals to velocity at B equals to 2gx. 2gx is the velocity at B. So now, so kinetic energy at B equals to half m v. What is v value? V value equals to v square value equals to 2gx. So direct writing 2gx, because vb square equals to 2gx. Now 2 cancel, so mgx is a kinetic energy at point B. Kinetic energy at point B is mgx. Now the total energy. Total energy at B equals to potential energy plus kinetic energy. What is the potential energy? Potential energy at B equals to mgh minus mgx is the potential energy, plus kinetic energy is mgx. So mgx cancel, so total energy at B equals to mgh. This is the total energy at B. So total energy at point B is also mgh. Now the body coming down and it reaches the point B, point C. It reaches the ground. So what is the height when it reaches the ground? Height becomes 0. So potential energy at C equals to mgh. H equals to 0. Therefore total energy at C, potential energy is 0. Total energy becomes 0. H equals to 0 at C. So potential energy at C equals to mgh, that equals to 0. Now find the kinetic energy. Kinetic energy at C. What is the kinetic energy? Kinetic energy equals to half mvc square. So we don't know the value of velocity at C. So you have to find out this velocity of C value. What is the velocity at C value? C. Then you will get the kinetic energy of a body when it reaches the ground. So at C, it is a freely falling body. So initial velocity is 0. V is taken as Vc, because as the velocity, we are finding the velocity at point C, and A equals to G, and S equals to covered distance H, total covered distance. Total distance from the maximum height is H, so total covered distance is H. Therefore from V square minus U square equals to 2AS. V square minus U square equals to 2AS. V is Vc square, U is 0, 2 is G, S is H. So Vc square equals to 2GH. No need to remove the square and put the root for the 2GH, because we need the value of V square value. Alright. So now we got the velocity at a C. Then find the kinetic energy. Kinetic energy at C equals to half mvc square. Half m, Vc value is 2GH. 2 cancel. So kinetic energy at C is equals to mgh. Kinetic energy at C is mgh. We got the value of potential energy at C is 0, kinetic energy at C is mgh. Then total energy at point C. Total energy at C is combination of potential energy at C plus kinetic energy at C. So what is the potential energy? Potential energy is 0, kinetic energy is mgh. So total energy at point C equals to mgh. Right? So we got the total energies at the position A, position B and position C. So once you see the energies at position A, total energy at A equals to mgh plus 0. Total energy at B equals to mgh minus mgx. This is potential plus mgx is a kinetic. And total energy at C equals to 0 plus mgh. See these three positions, the three equations. The first I am writing the total energy equals to potential energy plus kinetic energy. So at position A, at this position, at position A, total energy equals to potential energy mgh plus 0, and total energy at B equals to mgh minus mgx plus mgx. Total energy at C equals to 0 plus mgh. Right? So now observe this. At position A, the total energy is in the form of potential energy and no kinetic energy. The maximum value total amount of energy is in the form of potential only. Coming to the end point, the reaching point, see the position C, the total potential energy becomes 0. So here the total maximum energy converted minimum and minimum converted to maximum. At middle, see this potential energy mgh, some of the energy is lost and the same amount of energy is converted into the another form. So mgh is converted, amount of mgh is converted from potential to kinetic. Observing these three equations, we get the values. Finally, value is same. The whole amount remains unchanged, same, but the energy from one form to another form changes. Observe the point A, B, C. At A, total energy is in the form of potential. At B, some of the energy is in the form of potential and some of the energy in the form of kinetic. And at C, the total potential energy is converted into total kinetic energy. So from this, we conclude that the whole energy of a system, of a body, remains constant. It does not change, but the form of energy, one form of energy is converted into another form of energy. Right? So energy conservation is the energy cannot be created nor destroyed, but one form of energy is converted into another form. In a freely falling body, the potential energy at the maximum height, the potential body is in the form of total energy is in the form of potential, and at reaching the ground, total energy in the form of kinetic. It has maximum value, maximum velocity while it is reaching. When it is at a upper stage, the maximum height will be there, right? From these three equations we conclude that the in freely falling body the conservation of energy is proved. Next, in case of simple pendulum, we have another case, simple pendulum. What is simple pendulum? Simple pendulum is a mass suspended with an inextensible thread from a rigid support. For example, this is the rigid support. Some mass is suspended from the support, then this is said to be a simple pendulum. The length of the simple pendulum from midpoint of the bob to supporting point, this is called as a length of the pendulum, right? So this point is a reference point. This is the reference point. So here this is a simple pendulum. This point is a reference point for this one, and this is the length of the pendulum. Right? From this point, when it goes up, pull it and release it. Pull the bob and release it. Then from its reference point, it is going certain height. It goes some height. So this will be the maximum height. This will be the maximum height it can reach either side. Beyond this, it does not move. Right? So in extreme positions, at these positions, at this position, extreme positions, its velocity becomes 0. Because if it has velocity, then it further moves. Means it is not moving further. Here and here means this is the maximum height it can reach. So at maximum height, velocity becomes 0. And this is the point, reference point, so its height becomes 0. At this position, height becomes 0. And extreme positions, its velocity becomes 0. So for this point, here height becomes 0, here velocity becomes 0 at extreme points. So what is the potential energy at this point, at middle point? Potential energy at reference point is 0, because mgh, potential energy equals to mgh. So h is 0 at this point, h is 0 at mean point, so its potential energy becomes 0. Here the potential energy becomes 0. At this point, potential energy is 0. And when it reaches extreme left point, its velocity becomes 0. And it has maximum height. It reaches the maximum height. This is the maximum height of the body. Right? At velocity equals to 0 means kinetic energy equals to 0. Kinetic energy equals to 0. And potential energy is a maximum potential energy. Potential energy will be maximum, because potential energy is energy acquired by the body due to its position or state, and kinetic energy is due to its motion. So kinetic energy depends on velocity, potential energy depends on height. So velocity is 0, therefore kinetic energy is 0 at these two extreme points. This point and this point, kinetic energy becomes 0. See this, right? At extreme positions, potential energy will be maximum. And when it reaches to its reference point or mean position, At mean position, its potential energy, its height equals to 0, so potential energy becomes 0. And it has maximum velocity at mean position because we are not giving any push and pull, but it is moving left and right, so it has a maximum velocity. So kinetic energy kinetic energy at this point here, potential energy is maximum and kinetic energy is 0. Extreme positions, this is maximum at because v is 0, potential is maximum because height is maximum. At mean position, its potential energy be 0, velocity maximum, so kinetic energy is maximum. At this point kinetic energy is maximum, right? Observe this, when it is moving from A to C, at this position the total energy is in the form of kinetic, total energy in the form of kinetic energy. Potential energy is 0 here, potential energy is 0. But when it is reaches to this point, extreme point, its kinetic energy becomes 0. Maximum kinetic energy converted into 0 and minimum potential energy converted into maximum kinetic potential energy. The same observe the another point from mean position to right side extreme position. At mean position, it has a maximum kinetic energy and minimum 0 potential energy. Observe at the point B, extreme right position, the potential energy will be maximum. It is increases, right? Potential energy at this condition is maximum and kinetic energy is 0 from when it reaches from mean position to right position, right? From this we can say that the potential energy increases, kinetic energy decreases. As kinetic energy increases, potential energy decreases. Extreme points, see this extreme points, the kinetic energy is 0. Extreme points, kinetic energy is minimum. Extreme point, kinetic energy is minimum, potential energy is maximum. And at the mean position, kinetic energy is a maximum and potential energy is a minimum. So at extreme positions, velocity is 0, right? Velocity is 0, so kinetic energy is 0. This all energy is in the form of potential energy. Here also all energy is in the form of potential energy. At mean position, all energy is in the form of kinetic. Height is 0, so total energy becomes 0. At the another point, in between the extreme point and the mean position, you take the another position, then it's some of the energy is in the form of potential and some of the energy is in the form of kinetic. Observe these points. So, or any other different points, you can observe that. In case of simple pendulum also, we can prove the energy conservation, because at one point the energy is in the form of total potential is, and at this mean position the total energy is changed from one form of another form. At mean position, the all energy is in the form of kinetic. At extreme positions, all energy is in the form of potential. So we can prove the conservation of energy or energy conservation law in case of simple pendulum also. You can find the values of kinetic energy, potential energy in any point in a oscillatory path. You will get the sum of the energy is the kinetic and sum of the energy in the potential. But at the mean position, the total energy is in the form of kinetic and no potential energy at mean position. At extreme position, the total kinetic, this whatever the energy has at mean position is totally converted into kinetic potential energy at extreme positions. So, by this we can prove the conservation of energy law in case of simple pendulum. These are the two cases we have in our syllabus. So we proved conservation of energy in the case of freely falling body and in case of simple pendulum. This is a mechanical energy conversion from potential to kinetic, kinetic to potential. Next, we will discuss about the energy sources. Here we have the conventional, non-conventional energy sources or non-renewable, renewable energy sources. Non-renewable, renewable energy sources means the energy coming to the non-renewable. So as given in the name, non-renewable, we cannot renew it, right? So if once you use the energy, right, you are unable to reuse it or you are unable to reproduce it as time is going on and as the usage we cannot replicate it after using. That type of energies are called as the non-renewable. For example, we have these are the traditional energy sources: uh, coal, nuclear energy, and fuel, gas, natural gases. All these are the non-renewable. And renewable, which means renewed, we can renew it. Even after you are using some energies, you can use multiple times. That energy is called as a renewable energy sources. So coming to the non-renewable energy sources, non-renewable energy sources, non-renewable energy sources is duplicated and cannot be recovered once it is used. As human population increases, the demand for renewable resources increases. Here non-renewable energy sources are, it duplicates and we cannot be recovered. If you are using once, you cannot recover it after used. For example, oil, natural gases, coal, right? Nuclear energy. These are the non-renewable energy sources. Once you use the coal, then you cannot generate energy from the used coal. Once you use the gas, you cannot recover it or reuse it. As the same petrol, diesel, kerosene oil, all the oils you are using, once you use it, it is impossible to use one more time. Right? These type of energy sources are called as a non-renewable energy sources. Non-renewable energy sources are duplicated by uses of human beings and cannot be recovered from once it is used. As the population of world increases, these non-renewable energy sources uh, cannot be used because the demand is more, supply will be less. If you are using the non-renewable energy sources, after some years, hundreds of years or thousands of years, you can't able to get the non-renewable energy source like coal, because to prepare the coal and all these natural gases and oils, nature takes thousands of years. Thousands of years, after the thousands of years, the coal will be produced in the earth. So it is very difficult to get the required amount of energy from non-renewable energy sources as the human population highly increases. Therefore, we have to see for the alternate energy sources. Alternate energy sources are the renewable energy sources. Renewable energy sources means we can renew it. They cannot duplicate. When once you use it, even after use, you can use twice, you can use multiple times. The renewable energy sources are the sources in which can be used repeatedly and does not run out because it is naturally replaced. The renewable energy sources cannot be run out, cannot be empty because it is naturally replaced. For example, solar energy, wind energy, geothermal energy, tidal energy, biogas energies, biofuels, all these comes under the renewable energy sources. So renewable energy sources are the most demanding area, advanced area. All the whole world, all the countries of the world are doing research and working and producing the energies from the renewable energy sources. Some of the countries like China, Germany, France mostly depends on the tidal energy because their natural resources, the major renewable energy source is our sun. As we have we can extract energy in the form of solar energy. This main source for the solar energy is the sun. As our, especially in India, we have a naturally weather and good weather and seasonal time period. For example, summer 4 months, winter 4 months, rainy season 3 months. Like this, we have a lot of source. In all over the world, whatever the demand is there, more than that demand, the energy is supplied by the sun. The solar energy, if you concentrate on the solar energy, the whole energy is converted. The only problem is the cost effective and to store the produced energy. Then if you take energy from the solars, we will supply the power to whole the world without any destruction or disturbance. But only problem is we have to develop the devices to store the energy and economic cost effective situations. And wind energy, the most of the countries having coastal areas and hilly areas, so dry deserts, the dry desert area is the best area for the wind energy. So from the wind energy we can get the energy. As we have much scope in this area also, geothermal energy, it is a costly one. We need technology, we need equipments to produce the thermal energy. And tidal biogas, biogas is a cheapest one. One can easily manufacture a biogas plant in their household utilizations. We can generate the biogas by wastage of humans, cattle dung, and all the materials produced, right? Wastage in the homes. To generate biogas, we need not much cost, or we can construct a biogas plant for household utilizes with a very low cost. The most of the in Rajasthan and other states of our country, most of the villages, most of the areas are producing this biogas for their household utilizes. So this is the demanding area. Renewable energy sources are the demanding area, and we have to concentrate on the renewable energy sources, because as the non-renewable energy sources you are using, it produces pollution. It is not environmental friendly, and renewable gases are the environmental friendly. As the global temperature increases, the non-renewable resources are not good for the environmental view. So renewable sources are the pollution free, low cost maintenance, easily available from the nature. The only thing is we have to store it. We have to develop the technology, develop the devices to produce the at low cost and to transmit. So these renewable energy sources gives the sufficient energy for the whole world if we store the energy in a good manner without any interruption. So the renewable energy source areas are the next future for our environmental friendly, uh, global warming, global warming and greenhouse effect. All considering all these, this one is the best area to work on. So in this here, these are the renewable and non-renewable energy sources, right? Hope you got a concept regarding this renewable and non-renewable energy sources, and conservation law proofs in case of freely falling body and simple pendulum. So what we studied here in this class, we studied the conservation of energy, law of conservation of energy, and proof in case of freely falling body, and second case in case of simple pendulum. And we studied the renewable energy sources, non-renewable energy sources, example for these non-renewable and renewable sources, and importance of the renewable energy sources, right? We have the different applications of renewable energy sources, solar cooker, windmill, biogas in our syllabus. We will discuss these extensively in next class. Right? Hope you got the concepts, whatever we discussed in this class. Thank you. Thank you very much.